Hi, good afternoon, everyone. I'm Renoa. I will be your GTA for EML 4225 vibration and control. And for today's recitation session, I'm going to solve 4 problems. And if you have any questions or any concerns about this, feel free to reach out to me at my office hour. So let's start. So the first problem we're going to do is problem 1.1. So it says, there is given an amplitude of 0.20 centimeter. I'll be just converting it to meter. 0.002 meter, and also given a time period tau of 0.15 seconds. So we have to determine the maximum velocity, which is x naught max, and also the maximum acceleration, which is x double dot max. Now, we know that the displacement of a harmonic motion is denoted by, that's the displacement x. It's denoted by a sine omega t. Here a is amplitude, omega is the angular velocity, and t is time. So from that we can get the velocity by differentiating the displacement, which will give us a omega cos omega t, and you will get the acceleration if we differentiate the velocity, which will be x double dot, and this will give us minus a omega square sine omega t. So for the velocity will be maximum if this cos omega t becomes 1. So the value of maximum velocity x naught max will be equals to, here cos omega t 0, so it's a omega. Now we know omega can be written as 2 pi by period, which will give us 2. So let's just put the values. It would be 0.002 into 2 pi by tau, which is 0.15, and the result would be 0.0838 meter per second. Similarly, for maximum acceleration, which is x double dot max, the maximum value would be when the sine omega t becomes 1. So the maximum value of acceleration can be a omega naught square, which we can witness as 2 pi by tau over square. And if we put on the value 0.02 into 2 pi 0.15 whole square, you'll get the answer, which is 3.5 meters square per second. Next, we will go to the problem number 2, which is problem 1.3. Here it says a harmonic motion has a frequency of 10 cycles per second, and its maximum velocity is 4.57 meters per second. we have to determine the amplitude, period, and maximum acceleration. So we are given that frequency f is equal to 10 cycle per second, or we can write it as 10 hertz as well. The maximum velocity is x naught max equals to 4.57 meter per second. We need to find the amplitude A, the time period tau, and the maximum acceleration. So we know time period tau is equal to 1 by f, which we can write as 1 by 10. So the answer would be 0.1 second. This is the time period. Then we will find omega, which is 2 pi f. So if we put the values 2 into 3.1416 into f, we will get 62.832 radian per second. Next, we're going to find the value of amplitude. So we know that the maximum velocity, max velocity x naught max, is equal to a omega. So a will be equal to x naught max by omega, which is x naught max is given by 4.57, and we just found the value of omega to be 62.832. If we calculate it, the answer will come as 0.0727 meters. Next, we need to find out the maximum acceleration, which is x double dot max, and this is equal to a omega square. So let's put the value. A is equal to 0.0727 and omega square would be 62.832 square. If we calculate it, we'll get the answer to be 287 meters square per second. So now we move to the next problem, which says an RMS voltmeter specifies an accuracy of plus minus 50 decibel, and a vibration of RMS is measured as 2.5 millimeter. So we have to determine the millimeter accuracy as read by the voltmeter. Okay, here we go. So we have given here that the accuracy is plus minus 0.5 decibel. So by the definition of decibel, we can write that decibel is equivalent to 20 log 10 x1 by x2. And here, this value is 0.5. So now we're going to solve this. So we can write that log 10 x1 by x2 is equivalent to 0.5 by 20, which is equal to 0.0250. So x1 by x2 will be equivalent to 10 to the power 0250, which is equal to, if we calculate this, we'll get 1.0593. Now, multiplying this, we're going to multiply this to the voltmeter reading. To get the upper bound due to error. So, which will be, so our reading was 2.5 millimeter, and we're just going to multiply it with 1.0593, and that will get 2.6481 millimeter. So the millimeter accuracy read by the voltmeter would be, so is plus minus this value 2.6481, which is the upper bound of the error, and the reading 2.5 millimeter. So the accuracy is plus minus 0.148 millimeter. Next, I will move to a problem from chapter 2. So it's problem 2.7. Here you have given a picture of a figure of a flywheel. So it says a flywheel weighed 70 pounds and was allowed to swing as a pendulum about a knife edge at the inner side of the ring. and the period of oscillation was given as 1.22 seconds. We have to determine the moment of inertia of the flywheel about its geometric axis, or by this. So So this is our flywheel. And this is the knife edge P, and it's given as this diameter is 12 inch. So we can write that JP theta naught is equal to minus WR theta. Here JP is the rotational mass moment of inertia about point P. Theta double dot is the rotational acceleration. W is weight. R is the distance from center. And theta is the angle of rotation in radian. Now we know that theta naught, the rotational acceleration, is equal to minus omega squared theta. So if we put this value here, we can write Jp minus omega squared theta equals to minus WR theta, or Jp minus omega r theta equals to omega squared theta, which is WR by omega squared. Again, we can write Wi omega squared be 2 pi by tau squared. Now we are given W is equals to 70 pounds and tau is 1.22 seconds, and the radius is 6 inch. So if we put all these values here, we get minus omega 70 into 6 inches by 2 pi by 1.224 square. And calculating this, we will get 15.83 pound inch second square. Now we need to find the moment of inertia of the flywheel about its geometric axis, which is by point O. So that would be JO into JP minus M R squared, while JP minus W by G R squared. So the rotational mass moment of inertia around point P is 15.83, W is 70, and we're going to use 15.5 G in pound, and the is 6 squared. So if we put all the values, the answer would be 9.30 in pound inch by second square. Oh, so here the G would be equivalent to in inch per second, so it would be 386 inch per second square. So this is all I had for today. If you have any questions about any of this problem, please feel free to reach out to my office or the other two office hours. Thank you.